Hello and welcome to Maths by Sa.
My 12th lesson of D3, chapter number 9, exercise 9b, that is about the practical application of trigonometry in everyday life. And today's class is about the bearings. What are the bearings and how to calculate the bearings? These are the questions that have to be really clear to all of my students, along with the basic and further trigonometric ratios, because every lesson of mathematics is integrated with the previous lesson. If the previous lesson or link is weak, the new lesson will also be affected. And I hope you remember the rule for the bearing, that is NTC rule, okay. And if you are not clear about this, I will be giving the link of the lesson in the description box so that you can understand that what is NTC. NTC is that we have to start with north and we have to give the answer of the bearing with 3 digits if the angle is not coming in 3 digits, and we have to move in clockwise direction. Let's begin the discussion of today's class. Question 12 says, the figure shows 4 points on the level ground. A is due north of D, B is due east of D, and angle DBC is 37 degrees higher. And then we have to, it's given that AD length is 34, AB length is 57, and BC is 28 meters. We have to find the bearing of B from A. Bearing of B from A, the shortest distance from C to BT, and the bearing of D from C. Okay. I'll be discussing each part one by one. Okay, students, you can see the diagram is having 2 types of triangles. One is the right angle triangle and one is non-right or oblique triangle. So there will be different tools for the solution of the right angle triangle and the oblique triangle. The first thing is that we have to find the bearing of B from A. From A, it means that I have to draw the north at what point? At point A. At point 8, let me use the ruler. Okay, I have to draw the north at point A, and then what I have to do, I have to start the movement from the north A, and I have to stop at this point. Okay, now look, if I am able to take this whole turn, then I can have the turn of semicircle 180 degrees, but that I do not have. I have to stop at this place. So for that purpose, first of all, I have to find this angle, and then as the shape is making a semicircle, I have to take away this angle from 180 degrees to get the bearing of B from A. I hope, students, you are clear that how to find, how to calculate first part. This is north and this is the requirement of question. I have to stop at this place, but this we do not know about this angle. We do not know about this angle. So in order to get value of this angle, what I have to do, first of all, for the bearing of B from A, of B from A, I have to take triangle. Which triangle? This is ABD. In triangle ABD, A, B and D, A, B and D, and always make small diagrams. Give reference of the diagrams in your working so that the examiner can understand your working and message easily, because you will not be going to discuss your paper to the examiner. Your papers will be speaking on your behalf. Okay, this is A, this is D, and this is B, and this is 34, and this is 57, and I need to find this angle. So recall, Socato, Ca to. So Socato is sine opposite upon hypotenuse. opposite, as the reference angle is along this line, so this will be opposite and it's not given to us. Then let's talk about cos, adjacent upon hypotenuse. We are given with adjacent, so it means we have to apply cosine, trigonometric ratio cosine. So cos of angle A will be equal to adjacent 34 upon 57. 34 upon 57. So angle A is inverse cos inverse of 34 by 57. Inverse cos will appear in the beginning of this fraction, not at the end. This is a common error, and the display of the calculator must be on degrees. So I have to first press shift key, then cos, and display will have cos inverse at the top, cos inverse at the top, and then this is 34 divided by 57 and close the bracket, and this will be giving me 53.38 degrees. Angle A will be equal to 53.38 degrees, and which approximately will be equal to 53.4 degrees up to 1 dp. Okay, now for the actual requirement, that is the bearing of B from A. So bearing B from A. So we can see that now we have this angle with me, interior angle of triangle 53.4, and I have to take this much turn. This is making the semicircle, and I have to take away from 180 degrees, and this will become 180 minus 53.4. I have to take away this value from 180 degrees, and this gives me 126.61 degrees, 126.6 degrees approximately. I hope you are clear about the bearing part, and let's move to the second part. And let me draw the line here so that my students should not mix working with the other part. Okay, you have to present your working in orderly, organized manner. Okay, yes. Now the second part is the shortest distance from C to BD. Shortest distance from C to BD, it means that I have to drop the perpendicular from this point, and I have to reach to BD line, but with the shortest distance I can reach from C to BD line either in this way or in this way, but I have to remain on such position in which I have to be closer to BD line. In that case, this length will have to be perpendicular. This is a key point. This is the question that is coming often in O-level examination, that whenever we need to get the shortest distance, that will be the straight distance making 90-degree angle with the base. Okay, so what I have to do is that I have to drop the perpendicular from this point C to BD, and due to this perpendicular, I do not have letter E with me. I can create a right angle triangle in my diagram. So the second part is the shortest distance from C to BD, from C to BD. For that purpose, what we have to do, students, we can make a small triangle here in this way. This is E, where that length is meeting. This is C, and this is B, and this is 37 degrees angle. We have created a right angle triangle here, and this is 28. Now look, students, that we have to find this side. Let this side be H. Okay, and with the reference of 37 degrees, the angle which is given to us in this right angle triangle, this is opposite and hypotenuse, and opposite and hypotenuse, which trigonometric ratios, that is trigonometric ratio sine. Now in triangle CEB in triangle CE and B, this is opposite and this is hypotenuse, and opposite we are writing H upon hypotenuse 28, which is equal to sine 37 degrees. And now what we have to do, students, first let me know what is the value of sine 37. Sine 37 is 0.6018 H upon 28. Sine 37 is 0.6018, and shift this 28 to other side. H equals to 28 times 0.6018 multiplied by 28. This is 16.85. 85 height, which is approximately equal to 16.9, and measurements are in meters, so I'll write meters. So we have got the answer of this height as well. This is 16.9. I hope you are clear about this. And now it's the time for the third part, the bearing of C from bearing of D from C. Let's try to understand the question, that I have to start the movement from the letter which is coming after word from. C, I have to make the north, and I have to start the movement. If I'm taking this turn, it's really clear, this is 180 definite turn. And now if I'm reaching at this line, this is 270 degrees, and but I need this angle as well. So what we have to do is that if we observe the diagram carefully, almost we have the complete circle with us, but in that circle we do not have small portion of the angle with us. And what small portion? That is angle C, internal angle C. So what I will be doing, what do you think, students? What we can do here is that I have to first find this angle of the right triangle, and then what we have to do is that I have to take it away from 360 degrees. Now to apply cosine law to get a side DC, and that DC will be helping me in finding this angle, and after that, students, we will be able to reach at our requirements. So let's solve this part carefully. It requires attention. Okay, so first what we have to do is the bearing part, third part. I have to take triangle. In triangle, which triangle? ADB. In triangle ADB, it's your choice. ADB, it's your choice. Either you can apply Pythagoras theorem to get the base, or what we can have, we can apply the trigonometric ratio, any one of the trigonometric ratios. Either I need to have DB side, and I can apply either tangent, this is opposite upon adjacent, or what we can do is that opposite upon hypotenuse. So either I can apply sine, trigonometric ratio sine, or I can apply what? Trigonometric ratio tangent. It's up to you. I am applying Pythagoras theorem so that my students can recall Pythagoras easily. It's up to you, students, no hard and fast rule. This is A, this is B, 57 degrees, this is 90 degrees, 34, and I need to find DB side. So according to the rule, this is a hypotenuse. Okay, so 57 square will be equal to what? 34 square. 34 square plus this is the face opposite to capital A, so this will be A square. Now 57 square, 57 times 57 is 3249. 3249. 34. 34 times 34. 34 times 34 is 1156 plus a square. Okay, shift this to other side. 3249 minus 1156 equals to a square. 3249, this gives me 2093. 2093, which is equal to a square. And now in order to get value of length a, that is 2093, what I have to do, students, I have to take the square root of this. Try to show and perform all steps if you want to get and secure good marks. 2093 square root, and this gives me 45.74. 45.74, and which is approximately 45.7. This has come 45.7. Okay, now one of the problem has solved. Again, what we have to do is that I need to get actually this side, DC side. So for that purpose, what I have to do is that let me separate this place. Again, I have to take which triangle, students? The bottom triangle. I have to take the bottom triangle, that is DB, DB and C. Very interesting questions. They need your mental involvement as well, and you need to be really careful. This is DB, C, D, B and C, D, B and C. This is 45.7. 45.7. We just have got the answer. This is 28 and this is 37. Now first what we are going to do is we have to find this DC side, and DC is the face in front of B, so it will be B. And as the triangle is not the right angle triangle, so what we are going to do, we have to apply which law, either sine law or cosine law, but we are given with two sides and included angle, two sides and included angle, so cosine law. So B square will be equal to what? 45.7 square, 45.7 square plus 28. Let me confirm. Yes, 28 square minus 2 into 45.7 into 28 into cos 37 degrees. Okay, I have to take the squares carefully. 45.7 square, 45.7 square, this gives me 2088.49 plus 28 square, 784 minus cos 37.79 multiplied by 28 multiplied by 45.7 multiplied by 2, and this gives me 2043.86. Now first I have to add up 2088.49 plus 784. This gives me 2872.49 minus 2043.86. I have to take away 2043.86. This gives me 828.63 And now what we have to do, I have to take the square root on both sides. 828.63 square root of this will be giving me 28.78, and which is approximately equal to 28.8 meters. Okay students, it's a lengthy question but really easy and interesting. Okay, now I have calculated DC side. And now we are approaching towards the actual requirement of the question. Again, what we have to do, we have to take the triangle. Which triangle? Triangle is D, E and C. This is 16.9 and this is the value that we just have found, 28.8, and actual requirement is that we have to find angle C. Now observe that with the reference of this acute angle, what is 16.9 and what is 28.8, adjacent and hypotenuse, and adjacent and hypotenuse. So ka and ter, we need to apply cos. So in triangle what, DEC, this is cos C will be equal to adjacent 16.9 upon hypotenuse 28.8, and C equals to cos inverse of 16.9 upon 28.8. Okay, don't go anywhere because we are closer to our answer, and if you have missed any part and you're missing the lesson, you will not be able to understand the lesson. So 16.9 divided by 28.8 and close the bracket, and this will give me 54. Angle C is 54.06, and which can be approximately equal to 54.1. And now actual requirement of the question, degrees. Actual requirement of the question, that is the bearing of what? D from C. Okay, now look once again on the diagram that we need to find the bearing of the letter D from C. We have to start the movement from this point, we have to reach at this point, we have to reach at this point, and now we can see that we are completing almost 360 degrees turn, but we were not in the beginning having this angle of the triangle that we have calculated now. So that will be equal to 360 minus 54.1. So what I will be doing, 360 minus 54.1, this is 305.9 degrees. Very easy and very interesting question. Question is containing many parts, and it requires the understanding of basic and further trigonometry both. So please do understand the basic trigonometric ratios, Pythagoras theorems as well from D2, and further trigonometric ratios, sine law and cosine law and bearing. It requires the understanding of 5 concepts. Please watch my lessons, like, share and subscribe the channel, and do not forget to hit the bell icon to get the notification of every lesson in time. Thank you very much.